SkyWatch is a decentralized radar network with nationwide coverage. It accurately quantifies the motion of all objects in the sky. The network is deployed by citizens and the data is in their hands, giving them the ability to bring about UFO disclosure themselves. Radar measurements are uniquely suited to distinguish what is human tech and what is non-human tech because they measure kinematic tracks, the bizarre zigzag motions that UFOs regularly exhibit. However, citizens do not have access to these critical data. To understand why SkyWatch is the essential system citizens need for disclosure, it's necessary to understand what differentiates objects that could potentially be human-made from objects that could not be human-made. We call objects that exhibit special characteristics that indicate non-human origin objects outside the paradigm of science, or OOPS. These are objects that behave in ways that our current paradigm of science cannot understand or duplicate, even by trickery. You may be familiar with the so-called 5 observables. These characteristics mark key features associated with non-human technical vehicles. However, not all of these characteristics are unique to non-human craft. Balloons show no control surfaces or visible means of propulsion. Humans have made hypersonic missiles and planes. These do generate heat and sonic booms, but these signatures are not always detected. Humans have also engineered low observability stealth aircraft. And human-made airborne objects can and do fall into the water. The one characteristic that is unique to non-human technical vehicles is instantaneous acceleration. Human-made aircraft cannot and do not instantaneously accelerate as UFOs reportedly do. Therefore, if a nationwide network of citizen-operated instruments were to be deployed to reliably and accurately measure these kinematic tracks, these data would constitute a citizen-powered disclosure. What kind of instrument is best suited to measure kinematic tracks on a nationwide scale? To answer this, note that much of the existing UFO evidence in the public domain is in the form of pictures and videos. It's no surprise, however, that these data are inconclusive because a single camera cannot resolve distance. As such, size, velocity, and acceleration, in other words, kinematic tracks, cannot be determined. In order to resolve kinematic tracks, multiple camera angles would be needed on the same object. The useful range of a camera is about 10 kilometers. So in principle, nationwide coverage could be effected with about 1 million cameras permanently mounted across the countryside in a grid. But what about nighttime? What about clouds, rain, and fog? The ideal solution is passive radar. Passive radar can detect objects up to 100 miles away. It operates day or night and is not affected by clouds, rain, or fog. Combined in a network, they accurately measure object position and velocity to form kinematic tracks. Because of the exceptional range of passive radar, nationwide coverage would require a grid of only about 10,000 sites. Passive radar, as the name implies, is a receive-only technology. It piggybacks off of existing transmitters, such as the commercial FM radio transmitters that cover the entire nation. This is not a new technology. This is proven technology that was first used in the 1940s. Because it does not do its own transmitting, it is completely safe, undetectable, and can be made to be small, light, and inexpensive. My name is Mitch Randall, CEO and Chief Science Officer of Ascendant AI. As a volunteer research team member of Harvard's Galileo project, I developed a prototype passive radar network to detect kinematic tracks of skyborne objects. I'm the lead author of the peer-reviewed paper describing SkyWatch published in the Journal of Astronomical Instrumentation. This is the output from a SkyWatch passive radar receiver prototype I developed in 2022 based on a nearby FM radio transmitter as the source. The horizontal axis is bistatic range, and the vertical axis is Doppler frequency. The radar sees all of the objects in the sky at once within the detection radius. Aircraft are easily detected landing at a major airport about 52 kilometers away. The vision for SkyWatch is to develop an easy-to-set-up consumer radar receiver that allows citizens to become part of a nationwide passive radar network. The receivers communicate to servers that combine the radar outputs to obtain real-time kinematic tracks of all the objects in the sky throughout the nation. The kinematic tracks are sampled at up to 15 times per second and can accurately measure velocities up to Mach 6 and accelerations up to 2700 Gs. SkyWatch is designed to deliver accurate, scientific quality data. Its accuracy is continuously calibrated using the known position and velocity of commercial air traffic. As such, SkyWatch results can be a trusted source of data to scientific groups. This is, by itself, enough to enable citizen-powered disclosure. But when combined with a cell phone app and a public reporting database, these three pillars form a remarkably solid foundation from which to attain irrefutable confirmation. The associated cell phone app leverages the technology and ubiquity of cell phones to collect reliable scientific data. Besides providing a convenient method of reporting sightings, the app lets users participate in a nationwide network of insiders poised to capture video of rare events on a moment's notice. If a user begins to record video of an unusual object, nearby users are alerted to look in the sky in that general direction. If multiple users capture video of the same object from different locations, these videos can be later post-processed to obtain quantitative object position, velocity, and size. The app becomes even more valuable in tandem with the SkyWatch radar network. The paths of objects measured by radar are used to give advance notice to app users where to look for objects headed their way. The independent triangulation from their videos can then be combined with the radar data to form compelling multi-sensor reporting of UAP events. The SkyWatch public reporting database becomes a repository for sighting evidence of all kinds, including eyewitness testimony, stereo video, and radar data. The repository will use consistent formatting, AI-generated summary, and standard cross-reference tags to enable deep, efficient, and easy public searches. We have seen that kinematic track is the critical, undebunkable characteristic that distinguishes objects outside the paradigm of science. We showed that radar is uniquely suited to make that measurement. We showed that passive radar can be practically deployed on the nationwide scale needed to capture these rare events. We showed that the system constantly maintains calibration to ensure the results can be trusted to scientific standards. Summed together, SkyWatch then becomes the singular practical solution to empower citizen disclosure of non-human technical vehicles. The combination of the SkyWatch radar, phone app, and public reporting database form a solid platform to achieve citizen disclosure, yet the resources required to enact the plan are modest. We've demonstrated a prototype that proves the technology works. What is needed is the development of the consumer radar receiver needed to enable nationwide deployment and the distribution, maintenance, and support infrastructure that deployment requires. Ascendant AI has put together a plan for a team of 5 to 7 people to achieve full launch within 24 months. The SkyWatch app and database would be released within the first 12 months. The SkyWatch passive radar network would begin real-world evaluation in cooperation with a group for the scientific study of UAP within 18 months. Full release, including full production and mass distribution, as well as publication in scientific journals, would occur within 24 months. The team at Ascendant AI is ready and able to take on the full scope of this effort, but private philanthropic funding is needed. If you are interested, please contact us.